Hello, welcome to the presentation for Hydrology and Irrigation Engineering 17CV 73 for 7th semester civil engineering students. In this session 1, the contents I'm going to discuss are definitions uh, of the things that will come under the session 1, runoff, and what are the factors affecting the runoff. Coming to the definitions, the first definition we are going to discuss is total runoff. This is the part of the precipitation which appears in streams. Precipitation means rainfall. This is the part of the rainfall which appears in streams. It consists of surface runoff, interflow, base flow, and channel precipitation. The second definition is surface runoff, which is also called as SRO. See, this is the part of runoff on overland flow which reaches the streams. This is called as surface runoff. Another one we have to understand is direct runoff, which is also called as DRO, direct runoff. This direct runoff consists of surface runoff, interflow, and channel precipitation, but it does not include base flow. Since channel precipitation is small and interflow is uncertain, it is usual to include these two runoffs in surface runoff. Hence, there is no difference between direct runoff and surface runoff. Hence, total runoff is equal to surface runoff plus base flow. Since the base flow occurs in the stream after a longer time compared to surface runoff, it is necessary to separate the base flow and surface runoff in preparing hydrographs. Another one you should understand is hydrograph. Let's see what is hydrograph. It is a plot or a graph of the runoff or discharge in a stream versus time. So it's a plot of the runoff in a stream versus time. It may be developed for isolated or complex storms using stream gauging data. The area under the hydrograph gives the total volume of runoff, and each ordinate gives the discharge at the instant considered. It also indicates the peak discharge and the time base of the flood in the stream. So hydrograph is a graph which shows the or which is plotted runoff against time. Let's study what are the factors which will have an impact on runoff. We have discussed what is runoff, surface runoff, okay, direct runoff, all those definitions in the previous slides. Let's come, what are the factors which will have an impact on the runoff? Conceptually, in runoff formation, the rainfall is an input and watershed is the system on which the rainfall takes place and runoff is the output. So rainfall is an input and runoff is the output. It means that the parameters associated to the rainfall and the watershed, it's both the rainfall and the watershed will have an impact on the runoff yield. So it is the parameters which are associated to the rainfall and watershed will have an impact on the yield of the runoff. Let's see what are the factors which will have an impact on runoff. It may be categorized as climatic factors, uh, then catchment factors, etc. Coming to the climatic factors, the first one is climatic factors. that is type of precipitation or type of rainfall. So, what type of rain is there, or what type of snowfall is there, that will have an impact on the runoff climatic factors. Then, rainfall intensity. Rainfall intensity is another factor which will have an impact on the yield of the runoff. Higher the intensity of rainfall naturally causes more rainfall, and more rainfall means quite naturally more runoff. And even the duration of the rainfall. When the duration increases, infiltration capacity decreases, resulting in more runoff. And another one in the case of climatic factors is rainfall distribution. The distribution of rainfall in a catchment may vary, and runoff also vary more. More rainfall closest to the outlet. Peak flow occurs quickly. So, the important factor is the climatic factor. Under the climatic factors, you have type of precipitation. What type of precipitation? Is it a rain or a snow, or rainfall intensity? What type of rainfall intensity? High intensity quite naturally causes more rainfall. Then duration also plays an important on the amount of runoff. When the duration increases, infiltration capacity decreases, resulting in more runoff. And rainfall distribution. Distribution of rainfall in a catchment may vary, and runoff also vary. More rainfall closest to the outlet. Peak flow occurs quickly. Other climatic factors which will have an impact on the rain runoff are temperature, wind velocity, relative humidity, annual expanse. Affect the initial loss of precipitation because of this one. Initial loss of precipitation will have an impact on the initial loss of precipitation, and thereby it will have an impact on the yield of the runoff. Coming to the third factor is physiographic factors. Physiographic factors means the characteristics of the watershed and the channel. It's both. What are the factors? One is the size of watershed. See, if the watershed is larger, longer time needed to deliver the runoff to the outlet. That you have to keep it in mind. Larger the watershed, longer time is needed to deliver the runoff to the outlet. Whereas the smaller watersheds dominated by overland flow and larger watersheds by runoff. Dominated by overland flow and larger watersheds by runoff. So size of the watershed have an impact on the runoff. And shape of the watershed. The shape of the watershed also will have an impact on the runoff yield. There are different shapes, fan shape, then fan shape elongated. Then there are some watersheds which will have a broader shape. See in the slide, three figures are given. The first one is the fan shape, second one is the fan shape with an elongation, and third one is the broad one. Fan shaped runoff from the nearest tributary is drained out before the floods of the farthest tributaries, so peak runoff is less in this case. Whereas the broad shaped, all tributaries contribute here runoff almost at the same time, so that the peak flow is more in this case. So it's the size of the watershed also plays an important role, or will have an impact on the runoff, and even the shape of the watershed. So we have discussed about the runoff. Now, how the runoff is computed mathematically. Runoff computation. There are different methods and empirical formulas are used to compute runoff from a watershed. So some of the important ones have been listed here. A lot many runoff computational formulas are there. Some of the important methods are rational method, SCS method, Cook's method, infiltration indices method, hydrograph method, and empirical formulae. So generally we use rational formula method, and even the hydrograph method are the popular ones that are generally used. Let us see what is rational method. Rational method computes the peak runoff. Keep it in mind, it computes the peak runoff of small watershed. Peak runoff is required for design of hydraulic structures such as culverts, bridges, drop structures, and others. The rational method is appropriate for estimating peak discharge for small drainage areas of up of about 80 hectares with no significant flood storage. This method provides the designer with a peak discharge value but does not provide a time series of flow nor the volume of flow. This method follows the hypothesis that runoff is directly proportional to the area of watershed. Directly proportional to the area of watershed, and runoff is directly proportional to the rainfall intensity. Rainfall intensity must be for the duration equal to time of concentration of watershed. Accordingly, if the area of the watershed is A and rainfall intensity for the time equal to time of concentration of watershed is I, then equation of peak runoff QP can be written as QP is equal to CIA by 360. QP stands for peak runoff rate at meter cube per second. C is the runoff coefficient. I is the rainfall intensity in millimeter per hour for the duration equal to the time of concentration, and A is taken as area of watershed in hectares. So these are the references that are used. Thank you.